Mr. Clown for Clown Maths. Today we're going to be doing the Advanced Higher Maths 2022 exam paper, paper 2. Express in partial fractions 3x squared minus 3x plus 5 over x squared plus 5. So remember that means 3x squared minus 3x plus 5 over x squared plus 5 must equal a over x plus bx plus c over x squared plus 5. So that implies that the numerator 3x squared minus 3x plus 5 must equal, making this denominator cross multiplication is the simplest way, a x squared plus 5 plus bx plus c times x. So let's just put in some numbers for x and work out our a, b's and c's. So let's say at x equal to 0, that implies we get 5 on the left equals 5a on the right, which implies a just equals 1. Okay, let's do x equal to 1. That implies on the left we get 5 again. And on the right hand side we get 1 plus 5 is 6, so 6a. And plus b plus c, but we already know that a equals 1, so that means we've got b plus c just equals minus 1. And then we need to find another one, so let's try x equal 2 this time. So that implies our left hand side is going to be 2 2's is 4 times 3 is 12. 12 minus 6 is 6 plus 5 is 11. So we get 11 equals 9a plus 2 times 2 is 4, so 4b plus 2c. But we already know that a is 1, so 9 times 1 is 9, so that gives us 2 on the left equals 4b plus c, 2c. Dividing through by 2, we get 2b plus c equals 1, and we already know as well though that b plus c is minus 1, so we can just take them away from each other, and we get b equals to 2, which implies that c equals minus 3, because 2 becomes minus 3. So then, just to answer our question then, 3x squared minus 3x plus 5 over x squared plus 5 equals a over x, so 1 over x, plus bx plus c over x squared plus 5. Question 2, find the exact value of integral between 0 and 3 of 4 over 2x plus 1. So that equals 4 times the integral between 0 and 3 of 1 over 2x plus 1 dx. That gives you a log, so that's 4 times the log of 2x plus 1 times a half between 0 and 3. So that gives us 2 log 2x plus 1 between 0 and 3. So that's 2 times the log of 2 3's are 6 plus 1 is 7, minus 2 times the log of 1. That equals 2 times the log of 7 over 1, which is 2 log 7, or if you prefer, the log of 7 squared, which is a log of 49. Question 3 says, use a Euclidean algorithm to find integers a and b such that 634a plus 87b equals 1. Okay, so let's find the greatest common divisor between 634 and 87. So GCD of 634 and 87. So 634 equals 7 times 87. And it gives us a remainder of 25. So now 87 Well, that's clearly 3 times 25, and it gives us a remainder of 12. So now we've got our 25. Well, 25 is 2 times 12, giving us a remainder of 1, or 12 in other words equals 12 times 1 plus 0. And therefore we've shown that the greatest common divisor between 634 and 87 equals 1. So now we just need to work backwards. So starting off with 1 then must equal 25 minus 2 times 12. 12 must equal, looking here, must equal 87 minus 3 times 25. 25 must equal 634 minus 7 times 87. So we've got 1 equals 25 minus 2 times 12. So we're going to substitute 12 in now. So 1 equals 25 minus 2 times 87 minus 3 times 25. And we'll tidy that up as we go. So that means that 1 equals 25 minus 2 lots of 87 plus 6 lots of 25. So 1 is 7 lots of 25 minus 2 lots of 87. And now we can substitute our 25 in. So 1 equals 7 times 634 minus 7 times 87. Take away the 2 times 87 that we've still got. So 1 is 7 times 634 minus 49 times 87 minus 2 times 87. So 1 is 7 times 634 minus 51 times 87. So remember we started off with the statement that 634a plus 87b equals 1. Well, we've now got that in this form. We've got a must equal 7 and b must equal minus 51. Question 4. Use integration by parts to find the integral of x plus 2 to x plus 7 to the half dx. So let's make our u equal to x plus 2. Obviously that implies that our u dash or du is just 1. And then obviously our v dash is 2x plus 7 to the half. So we need to integrate that to find v. So that means that v equals, add 1 to the power, divide by the new power, times the differentiation of 2x plus 7, which is 2. That implies that v is simply 1/3. 2x plus 7 to the 3/2. So remember, integration by parts means that our integral, u times v minus integral of vu dash. Integral equals u times v, x plus 2 times 1/3 of 2x plus 7 to the 3/2. Minus the integral of v, which is again 1/3, 2x plus 7 to the 3/2. And we're timesing that by du, which is 1, so then that's just that. So we need to integrate 1/3 2x plus 7 to the 3/2. So as an aside, the integral of 1/3 2x plus 7 to the 3/2 dx equals 1/3, add 1 to the power, divide by the new power, times 2. 1/3 times, that'll be 1/5, 2x plus 7 to the 5/2, which is a 15th, times 2x plus 7 to the 5/2. So our integral equals 1/3 x plus 2, 2x plus 7 to the 3/2, minus the answer we just worked out, plus c. So we've got 5x plus 2, 2x plus 7 to the 3/2, minus 2x plus 7 to the 5/2, plus c, and that would be over 15. We can take out a common factor of 2x plus 7 to the 3/2 here. So we've got 2x plus 7 to the 3/2, 5x plus 2, minus, well, we've got 3/2, so I'm going to just have 2x plus 7 to the 1. And you've got plus c, and remember that's all over 15. So that gives us 2x plus 7 to the 3/2 times, let's just do this quickly, 5x minus 2x, so we've got 3x, and we've got 10 minus 7 is 3, plus 3, plus c over 15. 3 is a common factor here, so we can say that that is 3 times 2x plus 7 to the 3/2, x plus 1 over 15 plus c. Therefore, integral equals 2x plus 7 to the 3/2 times x plus 1 over 5 plus c. And we're done. Matrix A is given by this. Find the values of k so that the matrix is singular. So remember, if A is singular, then that implies that the determinant of A must equal 0. So we need to work out the determinant of A and then make it equal to 0. So the determinant of A, that just equals 1 times the determinant of this matrix minus 3 times the determinant of 2, 3, k and minus 7 plus 1 times the determinant of 2k, k and 18. So that just equals 1 times minus 7k minus 54. Take away 3 times minus 14, take away 3k, plus 1 times 2 times 18, plus k, take away k squared. So the determinant of A must equal, let's just tidy this one up. You've got minus 7k minus 54 plus 42 plus 9k plus 36 minus k squared. So determinant of A equals minus k squared plus 2k plus 24. So remember, singular, we've already said, implies the determinant of A equals 0. So minus k squared plus 2k plus 24 equals 0. That's k squared minus 2k minus 24 equals 0. To make it easier to factorise, we've got k and k, 6 and 4, minus 6 plus 4, and therefore k equals minus 4 or k equals 6, and we're done. The first three terms of a sequence are defined as x plus 5, 3x plus 2 and 5x minus 1, where x are a member of the natural numbers. So the first three terms form the start of an arithmetic sequence. Okay, let's start doing that. So let's say x plus 5 is u1. 3x plus 2 would be u2, our second term, and 5x minus 1 would be u3. Let's check the common difference between each of the terms. So let's do the first two. u2 took away u1. That is 3x plus 2 minus x plus 5. That equals 3x minus x is 2x. 2 take away 5 is minus 3. And then let's check the common difference between the next two terms. u3 minus u2. That gives us 5x minus 1, take away 3x plus 2. That is 2x minus 3. So since it's got the same common difference, that implies u1, u2, u3 form an arithmetic sequence with a being equal to x plus 5 and the common difference being 2x minus 3. Part B, find a simplified expression for the 15th term of this sequence. So un, remember, equals a time plus n minus 1 d, and we've already know that a equals x plus 5, d is 2x minus 3, and n is the 15th term, so 15. So we get u15 equals x plus 5 plus 15 minus 1 times 2x minus 3. So u15 equals x plus 5 plus 14 2x minus 3, which is x plus 5 plus 28x minus 3 tens are 30, 3 fours is 12, 42. So u15 must equal 29x minus 37. The sum of the first 20 terms of a sequence is 1, 130. Find the value of x. So remember, the sum is n over 2, 2a plus n minus 1d. Okay, so we want to find we know the sum of the first 20 terms of a sequence. So that's 20 over 2. 2 times a, but remember a is x plus 5. Plus n minus 1, well, just 19 times our common difference, which is 2x minus 3. Okay, so that implies we've got 10 on the outside, 2x plus 10 plus 38x minus 57. So that's 10 times 40x minus 47. That's 400x minus 470. And remember that equals 130. Should have divided by 10 first, but never mind. So we've got 40x minus 47 is 113. That gives us 40x equals a nice round number of 160, which implies that x must be 4. Question 7, the complex number z equals 3 plus I is the root of z squared minus 6z plus a, where a equals 0, where a is a real number. Part A, nice and simple, state the second root of z squared minus 6z plus a equals 0. Well, that is just going to be z equals 3 minus I. In other words, the complex conjugate of our original z. Part B says, hence otherwise find the value of A. So we've got our complex divisors. So we've got Z minus 3 plus I times Z minus 3 minus I. So we can expand our brackets in the normal way. So that gives us Z squared minus Z times 3 minus I minus Z times 3 plus I minus 3 plus I 3 minus I. It'll be a plus actually, because minus times a minus is a plus. So that implies we've got Z squared minus 3Z plus IZ minus 3Z again minus IZ plus 9 minus 3I plus 3I is nothing minus I squared. So that implies that we've got Z squared minus 6Z. These cancel each other. Plus 9. And then I squared is minus 1, so plus 1. Because remember, I squared equals minus 1. So that implies we've got Z squared minus 6Z plus 10. And our original, remember, was Z squared minus 6Z add A. And therefore, A equals just the number 10. 6c, the expression Z squared minus 6Z add A is a factor of Z cubed minus Z squared minus 20Z add B, where B is a real number. Find the value of B. So since it's a factor, we can just divide. And since it is a factor, the remainder will be 0. So we can just do that. So let's set up our long division. We've got Z cubed minus Z squared minus 20Z plus B divided by Z squared minus 6Z plus 10, because A is 10, remember, we've just worked that out. So Z squared goes into Z cubed Z times. Times and through by Z, then we get Z cubed minus 6Z squared plus 10Z. Taken away from each other, that gives us nothing, and it gives us 5Z squared, and we get minus 30Z plus our B on the end. So Z squared, that's squared, sorry, 5Z squared. Z squared goes into 5Z squared 5 times. So that gives us 5Z squared minus 30Z plus 50. Take them away then. That's nothing. That's nothing. And that gives us B, take away 50. But remember, Z squared minus 6Z plus 10 is a factor. So that implies the remainder must equal 0. So that implies B minus 50 equals 0, and therefore B equals 50. And we're done. Question 8, differentiate egg log x minus x with respect to x, and then part B, find the general solution to this differential equation. So part A, let's say y equals x log x minus x, and we're going to use the product rule on x log x. So we've got u is equal to x, we've got u dash is 1, and then v is log x, of course, which means v dash is 1 over x. And just a reminder, so we've got u dash v plus v dash u. So that's 1 times log x plus 1 over x times x, or log x plus 1. So that means that on this side, differentiating it, the y by dx must be log x plus 1 minus 1, because differentiating of x is just 1. So the y by dx in this case is just log x. Part B, hence find the general solution to this differential equation, dy by dx plus y log x equals x to the power of minus x. So our integrating factor from part 1 is simply going to be e to the power of the integral of log x dx. And we know then that is just going to be e to the x log x minus x. So that means our integrating factor is e to the log of x to the power of x times e to the minus x. So that means our integrating factor is just simply x to the power of x times e to the minus x. So we can just times both sides by our integrating factor. So we've got x to the power of x e to the minus x dy by dx plus y x to the power of x e to the minus x log x, and that equals the right hand side, which is x to the power of minus x times x to the power of x e to the minus x. So that implies we've got d by dx of x to the power of x e to the minus x times y equals e to the power of minus x. So x to the power of minus x e to the minus x y must equal the integral of e to the power of minus x dx. So x to the power of x e to the minus x y equals minus e to the minus x plus c. And therefore y is just minus e to the minus x plus c over x to the power of x e to the minus x. And that final answer can be left in a lot of different ways. Question 9 says the matrix A is given by 3 minus 2, 0, 1. Prove by induction that A to the n is 3 to the n, 1 minus 3 to the n, 0, 1 for all n a member of the natural numbers. So this is proof by induction, so let's prove for n equal to 1. So if n equals to 1, a to the 1 would be 3 to the 1, 1 minus 3 to the 1, 0, 1. So that equals 3, 1 minus 3, 0, 1, which equals 3 minus 2, 0, 1, which we already know equals a. So we've proved true for n equal to 1. So assume true for n equal to k. Therefore that would say that a to the k would equal 3 to the k, 1 minus 3 to the k, 0, 1. And now we need to prove it for n equal to k plus 1. So for prove true for n equal to k plus 1. So when n equals to k plus 1, a to the k plus 1, well that would equal a to the power of k times a, or since we're dealing with matrices, a times a to the k. And we'll just prove one of these. So a to the power of k times a, we already know what a to the power of k is, we've just worked out that that's 3 to the k, 1 minus 3 to the k, 0, 1. And we already know what a is, that's 3 minus 2, 0 and 1. So matrix multiplication, let's just give ourselves a nice big matrix. So we've got 3 to the k times 3. And we've got this times 0, which is 0. So that's our first element. We've then got 3 to the k times minus 2. And we've got 1 times 1 minus 3 to the k times 1. So plus 1 minus 3 to the k. Our next element, 0 times 3 is 0, 1 times 0 is 0. and our last element, 0 times minus 2 is 0, 1 times 1 is 1. So we need to tidy that up and make it look like a to the k plus 1, so we need k plus 1s appearing. So that equals, well, our first element, 3 to the power of k times another 3 is 3 to the k plus 1. Our second element, we've got minus 2, 3 to the k plus 1, then minus 3 to the k. So if I take 3 to the k out as a common factor of the terms in 3 to the k, that gives me minus 2 take away 1. And I've still got plus 1 on the end. So that's 3 to the k times minus 2, 3 to the k times minus 1. And then we've still got this plus 1 that isn't attached. And then you've got 0, 1, which is what we would need. So that equals 3 to the k plus 1. Minus 2 take away 1 is minus 3. So 3 to the k times minus 3 plus 1, 0, 1. So that's 3 to the k plus 1. 3 to the k times 3. Well, that's just 3 to the k plus 1 again, with a minus, 0, 1. So in other words, 3 to the k plus 1, 1 minus 3 to the k plus 1, 0, 1. That equals a to the k plus 1. So therefore, the conjecture is proved true for n equal to 1, assumed true for n equal to k, and proved true for n equal to k plus 1. So hence, by induction, a to the n equals 3 to the n, 1 minus 3 to the n, 0, 1, for all n a member of the natural numbers is proved true. And we're done. Okay, question 10 says solve the differential equation d squared y over dx squared minus 4 dy by dx plus 4y equals 9 sin x plus 13 cos x. Given that y equals 5 and dy by dx equals 0 when x equals 0. Strap in. This is going to be a long one. Okay, let's start off with our left-hand side and look at the auxiliary equation. So we have got m squared minus 4m plus 4 equal to 0, which is a perfect square. M minus 2 squared equals 0. So that implies that m just equals 2. Therefore, a complementary function is just a e to the 2x plus bx e to the 2x. Right hand side, we've got 9 sin x plus 13 cos x. So we've got y equal c sin x plus d cos x, which means dy by dx is simply c cos x minus d sin x, which gives us d squared y by dx squared equaling minus c sin x minus d cos x. And at this point, we substitute this back in to our differential equation. So substitute into, so we've got minus c sin x minus d cos x, that's our d squared y by dx squared. And I'll do this on separate lines so it's easy to see. Minus 4 c cos x plus 4 d sin x. So plus 4c sin x plus 4d cos x. And remember, all of this equals our right-hand side, which was 9 sine x plus 13 cos x. And we're just going to equate our sines and coses to find D and C. So let's just do some counting. So for our sine x, we've got minus c sine x, and we've got plus 4c. So we've got 3c sine x. And looking at our d's in terms of sine x, we have got 4d sine x as well. And then looking at our cos terms, in terms of c, we've got minus 4c cos x. And looking at our cos terms for d's, we've got minus 1d cos x plus 4d cos x, so we've got 3d cos x. And again, that all equals 9 sine x plus 13 cos x. So that implies you can clearly see here then, because we'll separate it out sine and cos, 3c plus 4d must equal 9. And our second equation, minus 4c plus 3d equals 13. So we've got simultaneous equations to solve. So I'll times the top by 4 and the bottom by 3. So we've got 12c plus 16d equals 36. And we've got minus 12c plus 9d equals 39. Adding them together, 16 and 9 is 25d. 39 and 36 is 40, 50, 60, 75. So d is a nice round number, which is 3. And we can now find c by substituting back in. 3c plus 4 times 3 equals 9. So 3c plus 12 equals 9. So 3c is minus 3. So c is negative 1. So we've got our c and d, so we know our particular integral. So remember, particular integral is c sine x plus d cos x. So that means we've got minus sine x plus 3 cos x, or making that look nicer, 3 cos x minus sine x. Well, that's where d equals 3 and c equals minus 1. Okay, we've got our particular integral. We just need to now find our general solution by adding on our particular integral to our complementary function. So for our general solution, plus 3 cos x now, minus sine x. Okay, so let's find our a's and b's by differentiating this and recalling what the question actually told us at the start, that if we go back, y equals 5 and the y by the x is 0 when x is 0. So we know this. Let's just take a note of that, remember, just to keep us right. Y equals 5, the y by the x equals 0 at x equal to 0. So if we differentiate it, we should substitute in, we should find a value now for a and b. So we'll just call that our Lie general solution. So our dy by dx is 2a e to the 2x. And then using the product rule on the second term, we're going to have 2bx e to the 2x. And then differentiating x gives us 1, so plus b e to the 2x. Cos becomes minus sine, and sine becomes cos. Okay, so let's substitute y equals 5 and x equals 0 in, and then also substitute x equals 0 and the y by dx equals 0 in. So x equals 0, y equals 5. So we've got 5 equals a, because e to the 0 is 1, plus b times 0, so that's 0, plus 3 times the cost of nothing, that's plus 3 then, minus sine of nothing, which is nothing, so 5 equals a plus 3. That implies a must equal 2. And then our second substitution, when x equals 0, the y by dx equals 0. So we're using the whole of this. We've got 0 equals 2a e to the 0. Second term will be nothing because we've got times in by nothing. Third term will give us b. Fourth term we've got nothing, and the fifth term minus 1. So we've got a nice equation. Substituting our 2 in, we've got 0 equals 2 times 2 is 4 plus b minus 1. That implies that b must equal minus 3. So therefore, our general solution is y equals 2e to the 2x minus 3x e to the 2x plus 3 cos x minus sin x. And we're done there, finally. Question 11. A curve is defined parametrically, which has the following properties. X is inverse tan of 2t. The y by dx is 6t, 1 plus 4t squared, and we've got y equals 5 and t equals 1. Okay, this is very interesting, but recall parametrically, if I write this, the y by dx, that's just the y by dt times the t by dx. Now, let's start off by looking at dx by dt then, which means we can get dt by dx. So looking at dx by dt, we know that first of all, x is the inverse tan of 2t. So we need to differentiate the inverse tan of 2t. So let's say x equals the inverse tan of u, where u equals 2t. Then obviously dx by du, using your formula sheet if you have to, is 1 over 1 plus u squared. And the u by dt just equals 2. So dx by dt is going to be dx by du times du by dt. So that's 1 over 1 plus u squared times 2. So we've got dx by dt is just 2 over 1 plus 2t squared, so 4t squared. So that implies that dt by dx is what we're trying to find out, is 1 plus 4t squared over 2. So remember, dy by dx is simply dy by dt times dt by dx. But we already know what dy by dx is. It's given to us in the question. That's 6t, 1 plus 4t squared. So we've got dy by dt times 1 plus 4t squared over 2 equals 6t, 1 plus 4t squared. So we can imply that dy by dt is simply 6t, 1 plus 4t squared Dividing by a fraction is the same as times and by its reciprocal, so 2 over 1 plus 4t squared. And you should be able to see that these cancel, and therefore the y by dt is just 12t. So we can integrate to find y now in terms of t. So y is going to be the integral of 12t dt, which is 6t squared plus c. So when y equals 5, t equals 1, that implies 5 is equal to 6 plus c, which implies that c equals minus 1. Therefore, y equals 6t squared take 1. And we're done. Question 12, let z equal cos theta plus I sin theta. Use de Moivre's theorem to state an expression for z4. So part A, nice and simple. z4 is simply cos 4 theta plus I sin 4 theta. 1 mark. No real problem there. Question B, state and simplify the binomial expansion of cos theta plus I sin theta to the power of 4. So we've got cos theta plus I sin theta to the power of 4. I'll need quite a bit of space for this one. So we've got 4 choose 0 of cos 4 theta. And then we'll have 4 choose 1 cos cube theta. I sin theta. And then we'll have 4 choose 2 of cos squared theta. I sin theta squared, which we'll work out in a minute. 4 choose 3 of cos theta. I sin theta cubed. And lastly, 4 choose 4 of just I sin theta to the power of 4. Remember, I is, so tidying this up. So 4 choose 0 is 1, so we've got cos to the power of 4 theta. 4 choose 1, well that's 4 factorial over 1 factorial, 3 factorial if you were taking your time, which is just 4. So you've got 4i. Cos cube theta sin theta. Then you've got 4 choose 2. So that's 6. And then it's cos squared theta, sin squared theta. But it will be minus because I squared is minus 1. Moving on to our next one, 4 choose 3. So that's 4 again. So we're going to have 4 cos theta sin cubed theta. And I cubed, well, I squared is minus 1. So minus 1, and then I've still got an I. So minus 4i. And the last one, 4 choose 4, is just 1, of course. I to the power of 4 is I squared is minus 1. So minus 1 times minus 1 is plus 1. So we're just going to have plus sin to the power of 4 theta. Part C says, hence show that cos 4 theta equals 8 cos to the power of 4 theta minus 8 cos squared theta plus 1. So part 1, we already know that cos theta plus I sin theta to the power of 4 from de Moivre's theorem is cos 4 theta plus I sin 4 theta plus 4i cos cubed theta sin theta minus 6 cos squared theta sin squared theta minus 4i cos theta sin cubed theta plus sin to the power of 4 theta. So we can see that this is made up of a real part and an imaginary part. So if we just equate the real parts, we'll end up with cos 4 theta. So equate the real parts. So that implies that we've got cos 4 theta equals cos to the power of 4 theta. Second term's imaginary, minus 6 cos squared theta sine squared theta. Next term's imaginary, but then we've got plus sine to the power of 4 theta. So cos 4 theta equals cos to the power of 4 theta minus 6 cos squared theta. Sine squared theta is 1 minus cos squared theta. And since sine squared theta is 1 minus cos squared theta, then we'll have plus 1 minus cos squared theta squared, because sine to the power of 4 theta is sine squared times sine squared. So now we've got everything in terms of cos. Tidying that up further, we've got cos to the power of 4 theta minus 6 cos squared theta plus 6 cos to the power of 4 theta plus 1 minus 2 cos squared theta plus cos to the power of 4 theta. So cos 4 theta equals 168 cos to the power of 4 theta minus 8 cos squared theta plus 1 as required. Okay, part 2, sine theta cot 4 theta can be written in terms of cos theta only. So sine theta cot 4 theta, well, that's just sine theta times the cos of 4 theta over the sine of 4 theta. So that equals sine theta 8 cos to the power of 4 theta minus 8 cos squared theta plus 1 all over sine 4 theta. Okay, part B told us that cos 4 theta plus I sine 4 theta equals, I'm just going to paste this in. So if we want to know what sine 4 theta is, we can just equate the imaginary parts, because we've got an I here, to the imaginary parts of this hand side. So equating imaginary parts, sine 4 theta must equal 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. Subbing it in, well, that's what we've got. That's going to be sine theta 8 cos to the power of 4 theta minus 8 cos squared theta plus 1 all over 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. Taking sine theta out as a common factor on the top, we've still got, but taking it out on the bottom as well so we can get rid of the sines. So sine theta is a common factor. So it's 4. We get cos cubed theta minus cos theta sine squared theta sines cancel, of course, so on the top we get 8 cos 4 theta minus 8 cos squared theta plus 1 over 4 times cos cubed theta minus cos theta times 1 minus cos squared theta for sine squared theta. And that equals 8 cos 4 theta minus 8 cos squared theta plus 1 over 4 cos cubed theta minus cos theta plus cos cubed theta equals 8 cos to the power of 4 theta minus 8 cos squared theta plus 1 over cos cubed plus cos cubed 2 cos cubed 8 cos cubed theta minus 4 cos theta. Question 13, the last one. A secure spotlight is situated 10 metres from a fence, straight fence. Spotlight rotates at a constant speed, makes a full revolution every 12 seconds. And the situation at time second, t seconds is modelled on the diagram below. L is your position of your spotlight. G is the point nearest to the fence on the spotlight. P is the position where the light hits the fence. Theta is the angle between these two positions, and x is the distance in meters from G to P, as shown. And we've got quite a big question to go through. The first one says, show that d theta by dt equals pi over 6 radians per second, and then dx by dt is 5 pi over 3 sec squared theta meters per second. We're then going to prove an identity and then find the exact value of dx by dt. So let's go straight into question A. So for question A, I've copied and pasted the relevant bits of the information, the diagram itself, and the fact that we've got one full revolution every 12 seconds. So for part A, we've got one full revolution, so 2 pi radians every 12 seconds. So 2 pi radians in 12 seconds means you've got 2 pi over 12 radians in 1 second. Simplifying that gives us pi over 6 radians. And therefore, the theta by dt is simply pi over 6. Nice and simple there. B, show that dx by dt is 5 pi over 3 sec squared theta meters per second. So if you look at our diagram, we've got a right angled triangle, so it's just SOHCAHTOA. So if you look, we've got opposite is x and adjacent is 10. So the tan of our angle is simply x over 10. That implies that x equals 10 tan theta. Dx by d theta must equal 10 sec squared theta. Tan goes to sec squared theta. Dx by dt then is what we're trying to work out. So dx by dt will be dx by d theta times d theta by dt. That's 10 sec squared theta times pi over 6. That's part A, remember. We worked that out. So dx by dt, 10 pi sec squared theta over 6, which is 5 pi sec squared theta over 3. So dx by dt is 5 over 3 pi sec squared theta meters per second is proved. Okay, we'll do a trig identity. We'll prove that 1 plus tan squared theta is sec squared theta. So let's just start with the left-hand side. 1 plus tan squared theta. Well, that's 1 plus sine squared theta over cos squared theta. Well, that's just 1 plus 1 becomes cos squared over cos squared. Plus sine squared over cos squared. That equals cos squared plus sine squared over cos squared. Cos and sine is 1, so it's 1 over cos squared theta, which is equal to sec squared theta. And therefore we've proved that 1 plus tan squared theta equals sec squared theta. Part C says, hence otherwise find the exact value of dx by dt when P is 5 meters from G. So recall dx by dt we've already worked out, and we've already been told in the question actually is 5 over 3 pi sec squared theta. But from the previous part, we know that sec squared theta is 1 plus tan squared theta, so dx by dt is 5 over 3 pi 1 plus tan squared theta. So from A, x is 10 tan theta. So when x equals 5, we get 5 equals 10 tan theta, which implies that tan theta equals a half, or 5 over 10. So we can substitute a half in for tan squared theta. So dx by dt is going to equal 5 over 3 pi 1 plus a half squared. Obviously at x equal to 5. So that equals 5 over 3 pi one plus a quarter, which is 5 over 3 pi, and 5 times 5 quarters. So that equals 25 pi over 12. So dx by dt equals 25 over 12 pi meters per second for our units. And we're done. This has been Clear Maths, and we have now finished the 2022 Advanced Higher Maths Paper 2. Good luck with the rest of your exams, take care, stay safe, and goodbye.